So what I want to talk about first of all, to give you a bit of foundation in, greenhouse gases and how they work and how they contribute towards, what we've been led to believe, how they warm up the atmosphere. And to do that, all we need to do is take a look at the molecules. So here we've got two molecules. They're both trimolecules and they're both greenhouse gases. On the left we've got H2O. As you can see, the red ball and the white ball's stick representation of the molecule, water. We've got the red is the oxygen and the white is the hydrogen atoms. So you can see there's two hydrogen atoms attached to one oxygen atom. The reason for that is because oxygen has a valency of 2. Now the carbon dioxide, the CO2 on the other side looks different, and that's because the carbon atom has a valency of 4. You might remember this from A-level science back in the school days when you was being taught about atoms and molecules. These would have been some of the ones that they would have discussed. I don't know whether they would have talked about the the greenhouse effect with you and how they interact with that, but we'll briefly touch on that. So what you need to remember is that all atoms have valencies, so they've got connecting points. So on the water molecule we've got an oxygen with a valency of 2 and a hydrogen with a valency of 1. When the hydrogen connects to the oxygen in this manner, two oxygens, because they've both got one valency each, or the ability to bond with only one other site, but in order to do that, the atom that it has to bind with has to have the ability to bind also. So in this case, the oxygen has an ability to bond with two atoms because it's got a valency of 2. The carbon is a bit of a sneaky creature, because what it does, it has a valency of 4, so it can bond with 4 other atoms, but in this case the CO2 molecule, as you can see, has a double bonding because the oxygen has a valency of 2, so it's got 2 bonding sites, so it can connect with both on left and right hand side of the carbon molecule. It can bond with 2 actual oxygen atoms with each in turn a valency of 2. Now, if you look at the bonding sites where these hydrogen and oxygen atoms and oxygen and carbon atoms bond, you'll see where the black and white lines enter the other colour. If you just imagine that at these zones of the molecule where they're connecting to others there's a little spring, and this is one of the reasons why they are known as greenhouse gases, because now, first of all, obviously when you think of the term greenhouse gas, you imagine in your back garden the greenhouse, heat coming through the glass and being trapped on the inside of the glass, and therefore it being warmer. And that is the case, that is exactly what's happening. It's going through the glass and then it's being bounced, deflected off the glass. But also, guys, what is not talked about in this matter is the deflectiveness of the actual radiation or photon coming from the sun, or heat radiation. So not only can they trap, but they can also deflect. And this is important, guys, because this bit of the picture, when they're talking about CO2, is never discussed. Because if it was, it wouldn't be too hard for people to figure out what was actually going to take place as a result of more CO2 or more water going into our atmosphere. I'm going to touch on that just briefly, but I wanted to give you a bit of a foundation on why we get the effect of a greenhouse. Now, they say that since the Industrial Revolution, 1760s, I'm going to pull up the little chart so we can see when that was in our history and just briefly talk about that. So they say that since the Industrial Revolution, you can see it marked here, in 1760, when it started, that from that point on we started to exponentially pump CO2 into the atmosphere, and as a result of that, the temperature of the Earth has got warmer. However, what that Australian guy was talking about the other day in the last video that I mentioned, that they only started the records from 1910. What they've done is omit some of the most critical information with regards to what really drives the climate, and what that is, as we've recently found out, is the sunspots. When they're more available, we have things called the modern maximum. You can see that taking place from 1950s to 2000. You can see it start to drop off from that point in turn. And when the sunspot activity drops off, so does the temperature. But what else is taking place during this period, that can cause other anomalies to happen, like glacial periods or returns to, like we see here in the 1650s, the little ice ages. It is actually driven by the output of the sun's intensity, and mainly in what we can easily record sunspot activity. So if we had, from the Industrial Revolution, put more CO2 into the atmosphere, then why did the climate of the Earth go down in the 1800s? Surely, if this was the starting point of the exponential increase in CO2 going into the atmosphere, we should have seen an exponential increase from temperature from the 1750s. And this was again the argument that the guy in the video was making to the Australian government. Again, they started their records of temperature from the 1910. So what I'm saying here is, from this alone we can see that CO2 is not increasing global temperature or even driving global temperature. What's driving the global temperature is what we see in this chart: sunspot activity and sun performance. So what they did was very smart. They started their records of temperature from 1910, and as you can see, from 1910 upwards we do have an increase in sunspot numbers. So it makes me wonder if actually they do receive the correct data, but they omitted it on purpose so that they could create a scenario to generate trillions of pounds of taxpayers' money to fund these projects that they knew was just an excuse to lose money in a way. I'm not the expert on that, but what I am the expert on is science. And guys, we have peaked the modern maximum and we are now on a decline, and as a result of two things. If we look at the last 3 solar cycles, which takes us to the present date, we will see an exponential decrease in solar activity. Now, what they will say from these scientific organisations is, yes, at this point in time we're at the end of solar cycle, we're at the trough, and for that reason there will be low sunspot numbers. But what they won't be able to admit is the data from the 2 previous cycles, solar cycle 23 and solar cycle 22. You can see that there was in greater numbers than what there was. So we're not just talking about one solar cycle and being at the end of the modern at the end of the solar maximum and now being in the solar minimum. We're talking about a trend that has been happening for at least the last 33 years. So we can expect to see the temperatures declining again, and that is exactly what we do see when we compare temperature today with the amount of carbon that is going into the atmosphere. Let me just show you another chart, and as you can see on the chart, CO2 still rising but global temperatures declining. Now I want to say something about this. This has been taken off my own private website, this one chart. So you know what, guys, there is an attempt to cover up these facts globally on the internet. There is an intention to do that. This was the only chart that has ever been removed off of Pole Shift News, and when I realised it, I didn't know how long it had been taken down for, but when I realised it, I put it back up, because this is a proof that slaps them in the face. They can continue like the magician on the stage that we've already witnessed how he's doing his tricks, and he's getting a bit boring now by continuing to say that CO2 is causing global warming and this, that and the other. But the fact is, it's not, and it no longer is. It's rising at the same level as CO2 is, and the reason why it has stopped rising at that level is because we peaked our modern maximum around the late 90s to the early 2000s, as you can see on this chart. And what does that mean? Is that the inertia over the last 33 years has now started to catch up. So let's go back to these molecules and what we should really be paying attention to. So, which one is the major culprit in the one that is at the moment possibly aiding the driven climate at the moment? Which one can we accuse out these 2 molecules of being responsible for changing climate on this earth, and in what direction is it changing it? Is it making it hotter? Is it making it cooler? Well, I think we can rule out CO2 right now, because when you compare the amount of water vapour in our atmosphere, it is considerably more abundant in our atmosphere. The other thing is when you put more water vapour into the atmosphere, and a little bit later we're going to talk about how this may be entering our atmosphere through just logical explanations that might lead to be the truth. How can water then lower the temperature of our planet as we expect through this grand solar minimum right now? Okay, if there is more water in our atmosphere, then it can do one of two things. It can pass through our atmosphere, or it can be deflected off our atmosphere. If there is more cloud formation and more dense cloud formation over the planet, and you can check recent satellite data to see that that is the case, there is certainly more cloud formation, so more water vapour or more water simply in our atmosphere than there ever has been, and it is a result of possibly what I believe cosmic radiation. This will be the connection between the two, and I'll just explain where the generator of all this water could possibly be being created in this next clip. So all I want to quickly do here, guys, is just bring to your attention something different happening over the southern hemisphere of our planet now. Yes, we have got interaction between polar and subtropical jet streams, and we know that this is an anomaly that's only been taking place over the last 25 to 30 years. And significantly over the last 25 to 30 years is when we noticed peak in the speed in which the magnetic poles were migrating over the northern hemisphere. So it jumped up a gear and it started to cover more distance in less time. Let's have a look at the jet stream widths over the southern hemisphere or over the Antarctic region. So as you can quickly denote, from the northern hemisphere we've got much wider jet streams and much more chaos going on down in the southern hemisphere of our planet. And yes, like the northern hemisphere, we've got interchange between the subtropical jet stream and the polar jet streams. As a result of the jet streams being wider, they are carrying more water vapour. But why over the southern hemisphere is it behaving like this and not so much over the northern hemisphere of our planet? What's different about what's taking place over our southern hemisphere? Let's get into that. So guys, if you want to later on go and have a look at the ozone hole closing the gap done by NASA, that's on YouTube. You know, you're more than welcome to, but you can just take it from my word that the ozone hole is closing, and we know that the ozone hole is generated through ozone, which is aerosols added to the environment down there, and it increases the ozone hole. What I propose made the matter much worse was the modern maximum. We had a lot warmer environment back in 2000 than what we did now in 2019. We've had a bit of considerable, well not considerable, we've had an amount of cooling already, which has been noted down in the Antarctic region. And it's baffling scientists. They can't work out why in a period of time where it's getting a bit cooler down there that the ozone hole is actually shrinking, and it should be reacting the adverse way. So it should be increasing, means it's getting cooler down there. Well, my theory to what is adding, first of all, to the size of the jet streams down in this region, and then being transferred from the polar region to the subtropical over the southern hemisphere, then interchange over the equatorial region into the tropical region over the northern hemisphere, is an interaction between the cosmic particles that are on the increase in our atmosphere right now. And we know why they're on an increase. First of all, we've got a weakened magnetosphere due to a pole shift, which looks like it could be going into its reversal stage from the next 4 to 7 years. And if that's the case, things are going to get much worse. So that hole probably might even close up completely as a result of more cosmic radiation. But secondly, we're in a solar minimum. And also a trend of solar minimums over the last 3 solar cycles. As a result of the sun going into a low period at this point in time, and has done, set a trend over the last 3 cycles of doing that, what has happened is first of all, from a sun's point of view, our heliosphere, which is like the Earth's magnetosphere, which protects the whole of our solar system, has shrunk. That in turn has let more cosmic radiation in. Our magnetosphere has weakened, and that in turn has let more cosmic radiation in. And specifically over the southern hemisphere, we know that there's now an interaction that can happen with aerosols and cosmic radiation. And when the aerosols have cosmic radiation ions attached to them, they become slightly bigger molecules until they are big enough to actually allow water to precipitate on them. And when they do, they move out of the polar jet streams with that water, and then they take that into the subtropical region. And what we see happening today all around the world is an extra atmosphere of water, which is leading to, you know, extra floods all around the world that are now slowly increasing. How it affects us, guys, is simply this, is that it's damaging crops at an alarming rate. It's changing the cropping seasons, and it is also, you know, making arable land unusable for growing crops because the seasons are unpredictable, and it is causing chaos around the world, not just with the climate, but also now with something that directly affects ourselves, which is the food production of the planet. We saw recently 10% of the crops destroyed in the United States, and globally we've seen the prices increase as a result of that. So what I'm saying to you guys is, you know, if we keep going back and back and back and saying, well, if we know this causes this problem, this causes this the problem, and then, okay, where does this problem stem from? It probably stems from the fact that we've got more cosmic radiation inbound on our atmosphere because of the weakened heliosphere as a result of the sun going in a low period of output, and that has been the trend for 33 years, or 3 last solar cycles. And we've also got a weakened magnetosphere, which also allows more cosmic radiation in. I know I'm repeating myself, but I'm just trying to put it in different ways in which you can understand what is causing the problem. And it seems that most of this problems that we all get are stemming from the southern hemisphere of our planet, and most likely from the ozone hole itself. And if scientists can't figure out why the hole's closing in a time when it should be increasing, then it's probably, you know, linked to the fact that we have more cosmic radiation inbound, and it will attach to those aerosol molecules that make up in turn the ozone hole. So in a nutshell, guys, I believe the reason we are experiencing a lot of these problems that we are right now is because we are stripping away the aerosols from the ozone hole, and in turn we are adding that extra water to our atmosphere, which is getting transferred by the weakened jet streams across the polar and subtropical jet streams, and then over the equator into the northern hemisphere, and depositing that water in those regions. There's a lot going on right now, guys, and I could keep going on and on and on about the pieces of this puzzle that gets put together. But if people are starting to ask questions, why are ice caps shrinking? Well, you know, or why is sea ice not expanding? You know, as a result of more water vapour freezing over the northern hemisphere. There is a lot of things that are not being accounted for. We know that from some of the research that we've conducted here, that it seems that the North Pole at the moment is dragging the Arctic climate towards Siberia as it goes, and as a result of that, some of the sea ice is going to be displaced on land, and sea ice is only measured for the amount of ice over the sea and not on the land. But if the Arctic climate is travelling along with the magnetic pole reversal, then it is going to be moving westerly towards Siberia, and it's going to be building up the ice pack over Siberia as well, and that needs to be accounted for. There's a lot of science not being accounted for in this picture. I think if it was, we'd be understanding a lot more about what is taking place on our planet. So guys, you know, our main area of concern is, of course, the magnetic pole and its reversal. Whether it is an excursion event or a completed reversal is irrelevant now, as we've denoted. The fact is it causes more cosmic radiation to be inbound. Now, one thing we can look at, guys, is some of the other impacts other than climate that cosmic radiation has on ourselves directly, and that is the fact that it can cause cancers, in ourselves and all the biodiversity on this planet, and we can also look into how long, before our Earth's magnetosphere starts to rebuild in strength. But at this point, guys, from what we've denoted, seems to fit very nicely. We've gone back probably to the cause of the problems. What we need to do now is focus on tracking that magnetic North Pole, tracking the intensities of the 4 magnetic poles that we have on this planet and those highest intensity regions, and just see where we go from here. And that's what our observatory is dedicated to, and that is what you guys, the few of you guys, do support. And I hope that you continue to support this, because we might end up at some point in the future, maybe not the too distant future, with an actual fact of what has caused all these problems. I'm just saying that all these things that I've mentioned in this video seem to fit the puzzle very well, in that they cause knock-on effects on other things, and it's only through going back looking at these effects that are happening around the world that you come to a conclusion which is almost probably going to be the case. You could use Occam's razor if you like. So guys, there's a link down there if you want to support what we do. We're going to make a few changes, guys, before the year's out. Now, I've promised you a couple of things. I said I'd get this cloud generator finished, and frustratingly, I'm just waiting for some other parts. The radiators, the fans have come. We've ordered the piping and the pumps that are going to now water cool the blocks that the Peltiers are on. Hopefully we can get minus 50 degrees and we'll have a good all-round cloud chamber where we can actually see these cosmic rays going in. Another thing I want to do is start monitoring the background radiation, which we might put up a page to do so we can see if that's on the increase. And a few other things. I did promise that once we got the cloud generator built, we'd build that CO2 laser, and the promise that we made to our patrons and everyone else that supported us, as a little thank you, we would put a little message in that laser and fire it out to space, and it should, if it doesn't come into contact with anything else, keep travelling long before you guys have left the planet. So it's a great little thing. Nobody else is doing that, and certainly you don't find people going back in as much detail to find out the causes of the problems that we do on this YouTube channel, this website, and of course this observatory, which sole purpose is to monitor one of the main anomalies that's taking place in our lives, guys. So if you want to support us, we've got a couple of days left in this month and we can really make an impact with a bit more support, then please do. The links are down there. If Patreon's not for yourselves and you want to make a PayPal donation, then you can do that. But remember this, guys, none of it is compulsory, but it would be great if more than just a few help support what we're doing, because there isn't another website out there doing what we're doing quite clearly and giving it to you guys as we get it. So there you go, guys. Enjoy the rest of the week. I will catch up with you probably over the weekend with an update on the cloud generator, and I'll say what I usually do. Bye for now.